Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to provide an example of how to sketch graphs of ellipses. So we have this equation here, 2x squared plus 3y squared minus 8x plus 6y plus 5 equals 0. And it's that equation ends up being elliptical in nature. You always want to start by writing out some sort of equation for standard form, pretty well no matter what geometry you're talking about. So here is the standard form of an ellipse centered at the point HK. So really what it boils down to is just finding the HKs and the A's and B's here, and then we can sketch it. So the first step is to make this look like this. So let's get the x's together. So we're going to have 2x squared minus 8x. I'm going to leave a little space here. Let's get the y's together. Plus 3y squared plus 6y. And then typically you'll notice there's a 1 here. You put the constants on the right. Now that was a plus 5. I know it looks a little like an S there, but so subtracting 5 from both sides. Now the idea here is that what we have to do is complete the square in these terms. The first step in completing the square is you want a 1 in front of this guy and in front of this guy. So let's factor 2 from both of these terms. And actually, here's where I'm going to leave my space that I'm going to need. And we can factor 3 from both of these terms. And again, leave a little space. Because what's going to happen is we're going to add numbers here and here to turn this into a perfect square. All right, in order to make this a perfect square, this needs to be a 4 here, so that this line is equal to x minus 2, the quantity squared. So what I'm going to do is add the 4. Now at this point I have tipped the balance, so to speak. I've added 4 to the left-hand side of the equation. And in reality here, it really isn't a 4, it's 2 times 4. So I've effectively added 8. So I'm going to go over here and put a plus 8 on the right for the fact that I've added that 4 there. This is now equal to x minus 2, the quantity squared. All right, let's take a look at this. We want to write this term as y plus something squared. Now because that's a 2, this something has to be a 1. So if you're not familiar with that, I'll go back and watch my video or other people's videos on how to complete the square. This would need to be a 1 so that the outer and inner terms give us a 2y. But the very last term, if you foiled this, would be a plus 1. So I'm going to come over here and put a plus 1. These are now identically equal. Now, even though I've added a 1, don't forget there's a 3 in front of it. So effectively what I've added is 3 times 1. So we're going to come over here and add a 3 to maintain equality. So just notice the left-hand side starting to look more and more like this. Over on the right, what do we got going on here? We're going to end up with 8 minus 5 is 3 plus 3 more. Looks like a 6, which is perfectly fine. All right, next step. Want to make it look just like this. So what we'll do is we'll divide everything by 6. And this is now going to be x minus 2 squared over 3 plus y plus 1 squared over 2 equals 1. Make sure I did that right. So 2 over 6, 1/3. 3 over 6, 1/2. All right, so we've got the majority of the work done. Now, we can do some comparisons here. I see that a squared is equal to 3, so a is equal to the square root of 3, which is 1 point, maybe 3 something. B squared is equal to 2, so b is equal to the square root of 2, and now we have pretty much enough to plot this thing. H is 2, k is minus 1. So this thing's got a center at the point 2 minus 1. So 1, 2, minus 1. Now that's the center there. That's not actually part of the ellipse, but we're going to use this to start sketching things. Now, horizontally here, the a value is 3, which is, you know, let me get a value for that. I'm sorry, not 3, square root of 3. Which is 1.73. So this is a pretty small ellipse. If I move over 1.73 units, 2.7 is maybe there. There's another point. Now this point right here, the x-coordinate would be 2 plus the square root of 3. If we move to the left now, 1, a little less than 2, or about there, that x-coordinate is 2 minus the square root of 3. And what we have here now is we have our semi-major axis here drawn. Now, that's the bigger of the two. Since this guy is bigger than this guy, that makes this the semi-major axis, and this way will be the semi-minor axis. All right, so starting again at the point, what are we at? 2, negative 1. If we go up square root of 2, now I believe that's about 1.4. Yeah, 1.41. So 1.4 is just barely above the axis, maybe about here. Our coordinate now is negative 1 plus the square root of 2. And then if we come down here, negative 1, and we come down about 1.4 units, we're about here. That coordinate now is negative 1 minus the square root of 2. We can kind of sketch the rest of it. Boy, I've drawn better ellipses. I guess that's going to be good enough. This is the semi-major axis, semi-minor axis. I think we're pretty well done here. So the idea behind graphing an ellipse is you want to put it in a standard form. A lot of times that will require completing the square, as I've done here. Once you have it in standard form, you should be able to pick off the h and the k by comparing, in this case, the x minus 2 to the x minus h, and the y plus 1 to the y minus k. Put a dot on your center. It's not actually part of the ellipse, but it's kind of like your starting point for graphing it. Find your value of a by comparing whatever's here to here, and your value of b for whatever's here to here. Go to your center. Left a, put a dot. Right a, put a dot. Down an amount b, put a dot. Up an amount b, put a dot. Sketch your ellipse. You always want to be sure and label these. These are key or important points with ellipses. So anyway, and I should label these as coordinates. So for example, this was 2 to the right, and then this was the y coordinate. So that coordinate is 2, comma, negative 1 plus root 2. This one right here was 2 plus root 3, and the y coordinate is minus 1. There we go. And so forth. And I'll let the video watcher here fill in the rest of the details. So I hope that this video helps demonstrate how to graph an ellipse. Have a great day.